Okay, all right, everybody. This is going to be a fairly quick little video on decimal multiplication. I know some of you are like, oh my gosh, why are we still doing this? But as I said in class, there comes a point when we just have to do the work. All right, so this is the year. This is the year. All right, hopefully this serves you. Watch this a couple of times, take some notes on it. There's a few key concepts that we're going to go over first and foremost. And the first one is going to start down here. Oops, wrong color. Sorry, it's going to take me just a few minutes to get used to this again. Right down here. Okay, so this is the number 200. Okay, now underlying all of these algorithms, everything we do with decimals, the big thing to remember is that these place values, the ones, the tens, the hundreds. If I have one group of 100, okay, this here is like one group of 100. If I break that up into its place value, the next place value to the right, if I make it a smaller place value, what we're doing is we're taking this one block of 100 right here, and we're going to turn it into 6, 7, 8, 9, 10 of the place value below. So in this situation, if I take this 200 and I say I don't want to have hundreds, like this big blue block, I want to have groups of 10. What does that mean? Well, if I have two hundreds, that's going to give me 20 groups of 10. So if I write that, watch this. 20 groups of 10, so this has to be the tens place value. And my ones is 0. Well, it looks the same as 200. But this can actually be in the tens place value, not the hundreds. Right? So keep this in mind. Whenever we borrow or carry, what we're doing is that we're either taking a group of 10, like this, and turning it into 1. So this is 10. I got 10 groups of 10. Well, that is literally one group of 100. Or I'm taking a group of, like a solid block like this 100, and I'm breaking it into 10 pieces. Now the crazy thing is that this works for every single place value. Okay, and decimals are absolutely no different. Okay, so if I have 1, let's take a big block. This is 1. And I have a decimal here. And I go one place value to the edge. Well, it takes 10 little things like this in order to equal the place value to the left. So when I go from a number to the right in the place value, what I'm doing is I'm breaking it in, I'm dividing it by 10. Okay, because now I have 10 little pieces. If we were to look at this visually, it physically looks like this. This would be like a chocolate bar with 10 pieces. These are equivalent. If this is all in there, if I have 10 tenths, like this, 10 tenths, that's the same thing as 1. It's identical. See how I have a 0 on the end? I could take this whole group of 10 and convert it into a 1. Now, opposite, if I have 1, I can smash it into 10. Now, what does it mean if I take one of these tenths? Let me grab this color, because this is where this makes a lot of sense. If I take this 1/10, here's 1/10. Okay, and I want to move that down into the next place value. Well, again, I have to divide this by 10 again. So now I would take this one little cube and I would divide it in 10 again. So this one little cube represents that whole black side. So look, I have 10 of them again, but they're all broken up. 10 pieces of a chocolate bar or whatever it is that you eat. Okay? So this is why in this algorithm, the number one thing we do, well, ask yourself, what do we do with the decimals when we are multiplying decimals? There's something we do with them. So let's say I've got a decimal here and I've got a decimal here. Okay? The very first thing we're going to do is we're going to ignore them. Why? Because our brains do much better when we can deal with whole numbers with multiplication. Okay, so I'm going to pretend those aren't there. So I'm actually just going to take them right out. Boom. Okay, because now what I have is I have 214 times 1 or 17. All right. Now, many of you have done this before, and the cool thing is it's no different. Okay, so what we do is we're actually going to start with the number in the ones column right here. This is what we're going to do. All right. Now, just to make this a little easier, what I'm going to do is I'm going to draw a red line to what I'm doing. So the first thing I'm going to do, remember we always start on the right hand side and we're going left. Okay, the only time we don't do that is in long or short long division. We always start on this right hand side. So I'm going to go 7 times 4. Now that's 28. Okay, now 28 looks like this. Remember what we just talked about. This is 20 plus 8. Ask yourself, how many groups of 10 is 20? How many groups of 10? This is 2 groups of 10. 2 groups of 10. That's why, remember, so this is going to the left. So I'm going to add 2 groups of 10. I put the ones digit, this ones digit, right where it should be, right underneath the number I'm working on. Now you notice I didn't carry the decimals down. Don't do that. Okay, this is a different algorithm. This is not adding and subtracting. We don't want to line up the decimals. Next thing I'm going to do, I'm going to go 7 times 1. Well, 7 times 1 is 7. Then I have to add these 2 groups of 10 that we identified earlier. So 7 plus 1 is 7, plus 2 is going to be 9. Wrong pen. Come on. There we go. Next thing I'm going to do is I'm going to take 7 and I'm going to multiply it by, that's right, 200. Well, 7 times, or 2, see it's in the hundreds. 7 times 2 is 14. Now I have nowhere to carry it over here. There's no more numbers, so I put both numbers down. If we look carefully at this though, it's interesting because what I have here is 14 in the hundreds column. So this is 1,498. Well, 7 times 200 is actually 1,400, right? 7 times 200 gives me 1,400. So you see how those are in the right spot? Awesome. So if we were using decimals to solve this, this gets crazy complicated because we have to think about, well, what's 0.7 times 200? It's quite challenging. So let's jump back into now that's the first part. Remember, when we're doing long multiplication, what we're doing is we're breaking it down into these place values. So the first thing I just did is I just did 214 times 7. Now, if we look at this next number that we have, I'm going to erase all that. You can scribble it out on yours. You don't have to have it carry over. And I just lost my 1 right there. My original number right here is 17. So I've already multiplied it by 7. So now what I'm going to do is I'm going to do 214 by 10. Okay, now so many different ways to think about this. I actually like to look at this and go, well, what's 10 times 4? Well, 10 times 4, because this is in the 10 spot, just like we see down here. This would be 40. Now, some students don't like that. So the other way to do this is I ask myself, is this number, is this 1, oh, come on. Is this 1 right there, is it in the ones column? No, it is not. So I'm going to put an X in the ones because I'm actually multiplying by groups of 10. So this is going to be, I can now do 1 times 4 because I put in this little placeholder. I like to use the X. You can also use a 0. Okay, I like to use the X because we're actually just confirming that it's not in the 10 or the 1 spot. Okay, now we do the same thing. I go 1 times 4 is 4. 1 times 1 is 1. 1 times 2 is 2. Now, those of you who are starting to see some of the patterns here will notice that this is in the thousands. How did it get there? Well, this 2 and this 1, what are we actually multiplying? This is 200 times 10. Look at the place where it is in the place value. Okay, so this is actually 2,000. Hey, that's right. We got it in the right spot. All right. So before we do anything else, the fancy bit with the decimals, we're just going to go back and take a look. Now, 7 and 10, that was our original number, 17. To get there, we must add them. So here what we're going to do is we're going to add these numbers together. So I start at the right 8 plus 0 is 8. 9 plus 4 is, well, it's 13. There's my group of 10. Right? Remember, 13 is 10 plus 3. Well, is 10 not one group of 10? So I'm going to take that 10 and I'm going to turn it into one group. And the 3 goes down. This is 4 plus 1 is 5 plus 1 is 6. And then I get 3. Now, if we weren't doing any decimals, we would be done. Okay, but we are doing decimals. So this is the part where we have to start putting our brains back together to start thinking a little bit. So our decimals we had placed here and here, I think. If not, that's where they are now. Deal with it. So we've ignored them up to now. If I have the number 100 and I put my decimal after the 1, well, what this means is that 100, I have to divide that by how many place values? Well, my original decimal would be here, right here. So there's one decimal place, there's two decimal places. So if I take 100 and divide it by 100, I'm going to get 1.00 or 1. Okay, so in this case, my first part of my problem, I've had to divide this by 100. Okay, because we're assuming our decimal point is at the end. This side, well, the decimal place is one decimal place over. So I started with 17. And then I divided it by 10, that one decimal place. That's what we do when we divide. It moves the decimal place. So this is going to give me 1.7. Okay, so when we look at this, at the top one here, I've divided by 100, then I divided by 10 again. So if this is what I have to divide my question by, well, in order to get the right answer, I have to do the same thing. So here I'm going to divide by 100. Remember, the number of zeros is the number of place values. So that's 1, 2. But then I have this other one that I got to keep going. So it's going to be 3.638. That's the only answer that makes sense. In class, we talked briefly about this notion of front-end estimating. Now, front-end estimating is my favorite way to do it. And what we do is we literally just take the very first number. We take the very first number. So in this case, it's going to be 2. Shouldn't have used green. And down here it's going to be 1, like so. And then I go, what, 2 times 1? Well, that's 2. So my answer has to be close to 2. So in this case, if I put the decimal, sorry about that, I haven't used this in a while. If I put my decimal at 0.3, that's not really close to 2. 3.6 is pretty close to 2. That's going to be the winner. But 36.3, that's way away from 2. That 36.3 does not make sense. Because when I front-end estimate, that's going to give me the closest indication of where my decimal is going to be. Okay? The other way to do this, which is the third place, what we can do here is we can take a look at this. How many numbers do I have? After the decimal? Here I have 1, 2. Down here I have 3. So in my answer, what was it? 3638. What I'm going to do is if I have 3 decimal places back, I'm going to add 3 decimals back into the answer. Okay, let's just do one more. Let's take 42.8 and we're going to times that by 0.14, something like that. So in this case, again, what are we going to do with the decimals? We are going to ignore the decimals. Just ignore them. We don't need them right now because it's all just place value. So we're going to start here, furthest to the right, and then we start multiplying. 8 times 4 is going to be 32. Remember, 3, 2 gives me 30 plus 2. This is 3 groups of 10. That's why I can move it up. 4 times 2 is 8, right here. Plus 3, 8, 9, 10, 11. Ooh, that one got tricky. Then I have 4 times 4 is 16, plus 1 is 17. Now, we can double check. What is 4 times 400? Well, that's 1600. So it's looking good so far. Now I'm going to move on to the blue one. So if we're ignoring those decimals, this is in the 10 spot. Okay, so 1 time or 10 times 8 is going to be 80. Or you can ask yourself, is this in the ones column? No. You'll also notice that the first number I put in, 1 times 8, look at that. It should go directly below the number that I am multiplying. Okay, that's a really good indication. Keep your things straight. Now, so I've done 1 times 8. 1 times 2 is going to give me 16, plus 1 and 6. 1 times 4 is going to give me 4, plus 1 is 5. Jink. I get add 2, 9, 7 and plus 6 is 13. 5 plus 1 is 6, plus another is 7. Okay, so we get 7. That's a number 3 there. 7391. Now, where does the decimal go? See if we can clean this up a little bit so we can see where it was. See if you can figure it out. How many decimal places? Okay, so I have 1, 2, 3 numbers to the right of the decimal in my question. Now, notice how I'm adding them. I have 1 here and 2 here. So we're adding these together. So that means I start on the outside and I go 1, 2, 3, right there. Now, does that make sense? Let's take a look. If I have 42, or let's say 40 times, 40 times 0.1, 0.1. Well, this is tricky. Okay? This is a little more advanced. But this means 10% of 40, so this is going to be about 4. Okay, so 0.7 doesn't make sense. 73 doesn't make sense. 739 does not make sense. The only one that makes sense is that. Right? I hope that serves you. If you still have questions, send me a private discussion or come and see me early in class and we can keep working on it until you get this skill mastered. All right. Thanks, everybody. Have a great, great night.